back with another video. This time I'm going to show you some things about what a struct is. A struct is kind of just like creating your own data type. It's a structure that you can put other variables in, data types in. I'll go ahead and jump right into it because it's not as complicated as some of other videos that we made. So yeah, first we're going to include the standard IO library as usual. We'll put the main function a little lower, right down here, add our return 0. Once again, you don't really need to do this because GCC will do it for you, but it's just good practice. 0 just determines that the function was a success. Anyways, we'll go ahead and make a struct. So here we are to make a struct, you simply just have to write struct, name it. I'll name it test for this. Brackets, enter, and now you can start putting your things in there. So for test cases, we're just going to put two things, two integers, int x and int y. And when you're done with that, you go down here, got to add a semicolon to the end. And there you go, you have your struct. So it looks maybe confusing. You might not have any idea why we would use this. I'll go ahead and, give you some examples. So we're going to declare a variable of this data type now that we have. Struct test. I'm just going to say data. And we've declared it. Now, what we want to do, what we've done is declared a variable named data of type struct test. So in order to access x and y, the integers, what we want to do is put the name data dot x. Now we've accessed x from this struct, and we're going to name it 5, assign the value 5. I'll do the same for y and give it 10. So they have values now. And let's say we want to do an addition problem. Int sum equals data.x plus data.y. So we know data.x is 5 and data.y is 10. So sum would be 15. Let's go ahead and verify this. Sum. Save that. GCC test.c /a.out, and sum equals 15. Worked just as we expected. So there is a lot more things you can do with structs than just this, basically. And you also may be wondering why we'd want to use this. So let's say we want to reuse something with integers x and y in another function. Again, we want to use it again. Do we want to redeclare the variables, or do we just want to redeclare a struct that has all the data types in it? You may think for just two integers there's no difference, and you're probably right. But as you start to add more things, int z, char, array 100, or char, I'll just call it string to make it stuff like that, blah blah blah. There's a lot of things, and you just want to reaccess it. Something I like to use it for is like statistics. Maybe you're trying to read an NBA stats, points, rebounds, assists, steals, blocks. You just want to have all the variables in one thing, in one data type, which would be what a struct could be used for. I'm going to erase these two for the sake and show you something easier to shorten this right here. If you put type def in front of here, you can now name this struct whatever you want right over here. And I'll name it test_t. So now, what does this change by declaring the struct? You just go here, and you only have to do test_t. So let's test if that works. GCC again. And there you go. It works just the same. Much easier in my opinion. So yeah, that's kind of just the basics on how to use a struct. You can play around with it. Now I'll kind of get into the memory of it, because we all know memory is one of the biggest things in C, one of the most important things in C, and partially why a lot of people just dislike the language. So we know that there are different data types they hold a different amount of bytes. Chars hold one. A string will hold however many chars you are putting it, and ints hold 4 bytes. I'll just kind of clarify that right here. So there are 2 integers here which are both 4 bytes. So if you want to do the math to figure out how many bytes this struct would be, I'm sure you could just guess that you would do this by adding 4 and 4, and you get 8, and you would be correct. So we can, I actually think it's value. We're going to print something here. We're going to use the size of function, test underscore t, to see the size of the struct. Let's run this. And the reason I used LU is because this is an unsigned long. It's not an integer. So we run that, and new line, of course. And I'll just write size. But you can see the 8 is over there, so it's 8 bytes. I'll even write bytes to make it a bit more clear. But you get the point. It's 8 bytes basically. Now, it's not as simple as you might think, because now we're going to add char b, which we know a char is how many bytes? 1 byte. Just 1. Simple. But that doesn't mean that it's going to be 9 bytes. It's 12. And you might be wondering why, because we know a char is 1, it's not 4. It would be 12 if all 3 of these values were 4, right? That's because, for the sake of memory, the compiler is going to add some padding in between. So it's going to take this 1 byte, and it's going to add 3 bytes of padding between the char and the integer. So over here, like where this would be in memory, there's going to be 3 extra bytes to make it, well, just 12. So what happens if we had 4 chars, because 4 times 1 is 4, right? Would that still be, I'll just already use X. Char B, char A, char Z, char P. I just chose the most random characters. And this would still be 12, because now there's no need for padding. You have 1 byte, 2 byte, 3 byte, and 4 bytes. So it matches to the 4, and you have another 4 from the first integer, another 4 from the second. There's definitely better ways to explain this with visualizing. I know I didn't do a good job of visualizing it. I just kind of explained it by words. So that's how I explained it. If you have questions about it, I can answer some of the comments or point you to some resources that will give you better help. But those are the basics of a struct.